What is the Doppler effect? And how does frequency change due to the Doppler effect? When the source of sound and the observer of the sound are both stationary, meaning not moving, the observer perceives or hears the actual frequency emitted by the source. Whatever the source is putting out, in this case 750 hertz, that's what the observer hears. But if either the observer or the source or both are moving, the frequency perceived is not that which is omitted. So in this example, you have the source of sound putting out 750 hertz, but they're moving towards the observer. And by moving, that changes the frequency observed by the observer. So the motion causes the perceived frequency to change, and this change is called the Doppler effect. And the change in frequency, we refer to that as a Doppler shift. So here's an illustration of a fire truck blaring its siren. Now when it's stationary, the sound waves being emitted in all directions, three-dimensionally, and somebody behind the fire truck hears whatever the person standing in front of the fire truck hears. There is no difference. But if the fire truck would be moving towards the right of the picture, what happens is as the sound is emitted towards the back of the truck or away from the direction of the movement, what happens is these waves now have to travel an additional distance because the sound is moving away. And in front of the truck, because the truck is moving forward, what happens is are the waves become pushed closer together. So as the waves are emitted, the truck is catching up to those waves. Consequently, what happens is the wavelength in front of the truck becomes smaller, and if we lower the wavelength, that's going to increase the pitch that we hear. And behind the truck, since you're moving away from those waves that are moving behind, what happens is that spreads the waves apart. And if you make the wavelength larger, the frequency decreases. So you probably noticed that if you're on the side of a road and someone blares a car horn as they pass you, or if you're watching NASCAR racing or something like that, and you hear the sound, the vibration of the engine, you're going to hear as the car or the siren comes towards you, you will hear a high pitch as it moves away from you, you'll hear a lower pitch. It'll be something like, and that's probably a sound that you're familiar with. As the vehicle approaches you, there's a high pitch, and when the vehicle moves away from you, there's that low pitch. So as the truck moves forward, what happens is moving away from the sound waves causes the wavelength to lengthen, and moving with the sound wave causes the wavelength to become compressed or shortened. Consequently, moving with the waves causes a high frequency, and moving away from the sound that's being emitted causes the frequency to be perceived by the observer as being lower in frequency.